Hello again. We are going to see now how to reshape arrays and how to stack arrays. So we are going to see these examples to to explain you how reshape works. First of all, I'm going to create a one-dimensional array, which is going to be, remember that np.arrange is going to be consecutive numbers, integer numbers from 0 to 5. 6 elements from 0 to 5. This way. This is x, okay? This is lower x. And now I'm going to reshape this one-dimensional array into 2 rows and 3 columns, okay? And this is going to be a 2-dimensional array because it has 2 rows and 3 columns. So if I reshape, if I call this function over here, the result is going to be a copy, okay, it's like a copy of x with rearranged values. So let's see what happens now. Now x is going to be 0, 1, 2, 3, 4, 5. So remember that this the arrays, numpy arrays work in rows. So the first row is going to be 0, 1, 2. And the second row is going to be 3, 4, 5. The shape is 2, 3, which is the same shape that I told him to use, 2, 3. So this is just as expected. If instead of creating a 2-dimensional array of 2 rows and 3 columns, I try to do a 1-dimensional array, I try to create a column vector. Remember that a column vector is going to be a 2-dimensional array with only 1 column. Then the number of rows is going to be the length of the original array. In this case, what I have is this set variable is going to be the array x reshaped according this to these rows, this number of rows and this number of columns. Okay, so we have len x is going to be the number of rows and 1 is going to be the number of columns. And in this case, what I have here is this array over here. Notice that now we have this 0, 1, 2, 3, 4, 5. We have now in form of a column. And the shape is 6, 1 because we have 6 elements, 6 rows and 1 column. The problem with this way of writing this, we could numpy has a quicker way of writing this, or an easier way, which is using the -1, the -1 number. If we use a -1 instead of len x, then what we're telling numpy is okay, reshape me this array x. I want to be reshaped in 1 column over here, and here use the number of rows that it's needed in order to obtain in the end only 1 column. So of course numpy is going to use the number of rows which is equal to the number of elements of x of this one-dimensional array. So this is equivalent to this call over here. So you will see a lot of -1 1 or 1 -1 in order to do exactly this thing over here, which these are both equivalent ways of doing the same. And another way, well, you can notice here this here, okay? So here we have set 2 is going to be the same array. Notice the same array with the same shape. And this is also equivalent to this expression over here. This is slightly different. Okay, instead of using the reshape function, which is more general and it's also value for 2-dimensional arrays, what this is going to do is to make a new, it's like a slice of x, where we are using all the elements of x here, and here I'm adding a new axis. So this is quite strange because x in principle it's only a 1-dimensional array. So I'm telling here to use 2 dimensions, and this is why I'm using here np.newAxis. Okay, this is some kind of a function. This is an attribute of the numpy library to tell to tell in this line of code that I'm going to use a new access to create this set3 function, this set3 blah, 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 this set3 variable. Blah. So in the end we obtain the same result. Okay, the result for these three set2 and set3 arrays are the same. Another way of another thing that may be interesting is to, instead of reshaping an array, well, we can also use this function for 2D arrays. Okay, so we will see it with an example. Yes, I'm going to use the example now. So I'm going to compute this one over here, and I'm going to make this x. Okay, this x over here, which is this. No, yes, this is different because I used the same function. What is wrong? X. This it was, yeah, I'm sorry. Okay, so I'm going to make this thing over here, x equal to pi dot array, and we had exactly pi dot arrange. Arrange, it was 6, and then I'm going to do the reshape with the -1 thing, just like before. So in the end we have, no, I didn't want to do that, I'm sorry, I wanted to do this. In fact, I'm going to do this thing over here. So what did I do here? I reshaped this one-dimensional array from 0 to 5, 0, 1, 2, 3, 4, 5. I reshaped it into a two-dimensional array because here I have 2 dimensions with 2 columns. Okay, 2 columns, and here, since I have 2 columns and I have 6 elements, then this I'm saying Python, make this whatever is needed to make it work. So the only way to make it work is to make this a 3, because I have 3 elements, so I have to make this a 3. So it has 3 rows and 2 columns. And if I write this over here, instead of 2 columns, I write 3 columns, then the result is this thing over here. Okay, 0, 1, 2, 3, 4, 5. The point is that if I try to reshape this x over here, I can do exactly the same. I can reshape this this array, this two-dimensional array in this case. Now I'm going to reshape it in -1, -1, 2, and the result is the same as we had before. Notice that we have here 0, 1, 2, 3, 4, 5. So this is going to take the first 2 elements to make the first row, because the result has to be 3 rows times 2 columns. So it's going to take the first 2 elements to make the first row, then the second 2 elements to make the second row, which are 2 and 3, and then the third 2 elements to compute the last row, which is 4, 5. So this is the result. So reshape can be used for one-dimensional and for two-dimensional arrays. And another way of another thing that can be useful many times for two-dimensional arrays is to flatten the array and generate a one-dimensional array. So there are two functions that we're going to use, which is flatten. One of them is flatten, and another one is wrapple. So if we use flatten, then this is going to do something similar to this thing over here. X dot reshape -1. I don't think this works. I think so, but I'm not sure. Let's hope. Yes, it works. So this is saying, okay, I'm going to put this everything in only one dimension, and the number of elements has to need to have, well, the number of elements, the total number of elements, the size of this X two-dimensional array. Okay, so this is going to be this is exactly like flatten. With flatten, what we obtain is exactly the same. Okay, we obtain here a reshape of -1 with nothing else, and we're saying I'm going to obtain a one-dimensional array, and this is, well, for a one-dimensional array also, but only with this function flatten. Flatten is usually more used than this way of doing it. And but notice that here in all these things, what we are doing, we are starting from X, okay? And notice that when we flatten, we go in the order used by X. Okay, the order of the elements is first the elements of the first row, then the elements of the second row, and so on. So here I have first the elements of this first row, then the elements of the second row, and then the elements of the third row. And here I have that the order of the elements are, well, these elements, because I only have a one-dimensional array. If I wanted to do this flatten, but in columns instead of rows, then what I had to do, I would have to make the transpose and then the flatten. So if I do this, if I do the transpose and then the flatten, notice that when I transpose the matrix, this is going to give me, okay, now instead of this X over here, okay, this array, I have the transpose, which is 0, 3. 0, 3 is going to be the first row, 1, 4 is going to be the second row, and 2, 5 is going to be the third row. Okay, 0, 3, 1, 4, 2, 5. And then when I flatten this array, the result is 0, 3, and then 1, 4, and then 2, 5. Okay, so this is the result of flattening the array. The order of the elements are always given by the rows of the matrix that I'm flattening. And that is why in this case, if I wanted to do it by columns, first I have to transpose the matrix. Okay, and lastly, I'm going to talk about how to stack arrays. And we're going to use stacking quite a lot when we use when we do some of the machine learning functionality. And that is because we usually, well, we are going to use something like this many times, okay? So if we start with with an array, with a one-dimensional array that we randomly generate, or just a one-dimensional array, and then I have another one-dimensional array, and if I want to stack both one-dimensional arrays into a two-dimensional array where each column is is each of these one-dimensional arrays, okay? So I have, this is going to be, these two one-dimensional arrays are going to be stacked into columns of the new two-dimensional arrays. So I have here in this case, when I run this code, I obtain the first array is going to be the array of ones. The second array is going to be an array of consecutive numbers from 1 to 5, because here I had from 0 to 4 and then I added 1, so here I have 1, 2, 3, 4, 5, and then when I stack both arrays into a two-dimensional array, I have the first column is going to be the first array that I'm stacking, and the second column is going to be the second array that I'm stacking. And notice that here we have, this is a floating type, a float array. Okay, this array is formed by floats, and this array is formed by integers. So when I stack these two arrays, in order to make it work, it's going to convert all the elements to the more generic one, which is in this case floating numbers. So we have that both columns in this case are floating numbers. Instead of column stack, we could also use horizontal stacking. Okay, And in this case it's something quite similar, but it only works with arrays of the same dimension. So in this case it's more or less the same idea. We are going to stack horizontally, so if I have an array, then I'm going to stack another array horizontally, so next to it, and the other one is going to be next to it too, and so on. And if I try to do, we can do it with this function over here or with this thing which is not a function, and this, it's something different. Okay, notice that here we are concatenating these two functions over here in the horizontal axis. And in this case we can also do vertical stacking. So if we stack using vstack function or R, we are going to stack in the vertically, so we are going to append the arrays vertically or by rows, like this says over here. Okay, so, and this only works again only with arrays of the same dimension. And this is it. I think it's easier to use this one over here. Sometimes we will use some other, but mainly we will use this example over here. Okay, this way of stacking values. And that's it. That's all that we're going to see for numpy arrays, which is not small. I mean, we've seen a lot of things, many things. And what you need to do right now is to play and to make some exercises and see if you have understood the concept. And if you have not understood anything, then just look for information, maybe watch again some video or some part of the video or whatever. Okay, so we'll do some exercises of this in the classroom, and we'll see you on Monday. Okay, bye.